Hey guys, so today we're going to be doing investigation 8 in this video. We did investigation 7 in the class during class at the end. So we're just going to move on and do investigation 8 here. Um, so first off, we're going to revisit our properties of exponents. I'm going to do this somewhat quickly since this will be the second or third time we've gone over it. Um, so when we have two numbers of the same base but different exponents multiplying with each other, we keep the base and then our exponents are going to add together. So we have a times n, or a to the n times a to the m. So that'll be the same as a to the n plus m. Moving over to the left, we have the same base, different exponents, but instead of multiplying, we're dividing. So when we have that, we're going to keep the base just like before, but our exponents are going to subtract this time. Okay? Now, we've seen this before. We have a number raised to a power raised to another power. Um, so when we have this, our exponents are going to multiply. So we have our base of a, and then it's n m. And remember, when there's no operation between the two, it is multiplication, okay? So moving over to our right, we have a over b, so different bases, but the whole thing is raised to an n. So when we have that, our n kind of distributes almost. So it'll look a to the n over b to the n, okay? Same exponent, but different bases. Same thing over here, the n is going to distribute. The only difference is that it's multiplication now instead of division. So it's an times bn. And lastly, this one, which we talked about a lot more in investigation 7, but when we have a base raised to a negative exponent, what happens is that we flip from numerator, and in this case numerator, to denominator. So it's 1 over a to the n instead of a to the negative n. And just keep in mind, if we had this, we had a 1 over a to the negative n, that will be flipped. So, but instead of from numerator to denominator, it's a denominator to numerator. Okay, so quick run through. Again, if you have questions on these are very important as we move through the unit. Um, so we need to make sure we understand these, okay? So let's move on, and we're going to use our properties of exponents that we just talked about, and we're going to apply them in solving equations, okay? So let's look at number 1. We have 3 to the 2x plus 5 equals 3 to the x plus 4. When we have the same base in an equation here, we can almost disregard the base, okay? Because the exponents have to be equal in this case. So we can just rewrite just the exponents. So we have 2x plus 5 equals x plus 4, okay? So now we solve for x. Pretty simple. So we subtract the x over, we get x. We subtract the 5 over, and we get x equals -1. Now you can check in your calculator for that. I'm going to do a written out check over here. Just remember that this is for number 1. So we have 3 to the 2 to negative, or to the 2 times -1 plus 5, and that should equal 3 to the -1 plus 4. So we know this side is going to be 3 to the third. Now we need to check to make sure that this exponent will equal 3 as well. So when we do it visually, we have 2 times -1, which is -2, plus 5. So that is also going to be at 3 to the third. We don't need to solve it because these are equal, so we know that this is right. Now we don't have to do the check for every one. I wouldn't say it's a bad idea to just plug it in your calculator to be sure, but unless it tells you to do the check, I wouldn't bother. But what we're going to do now is go over number 4. We're going to skip 2 and 3. So 4 is interesting because we have multiple 3's on either side of the equation sign. But we're going to use our exponent properties that we talked about before, and we're going to try and solve this. But I'm going to have you try it on your own. So pause the video and go ahead and try, and I will come back with the full process of how to solve this, okay? All right, so go ahead and pause. So as you can see here, I did a little crossing out, but remember when we multiply numbers with the same base with different exponents, the exponents are going to add. But no matter how many times you multiply that base, you can add all of the exponents. So I'll have 3 to the 2 plus, it's going to be plus a negative, which is the same thing as minus, plus the exponent from the third 3, which is x plus 8. Okay? So now on the left side, I have 2 minus x plus 8. The minus x and the plus 8 cancel, and then it's 2 plus 8, which equals 10. So that's how I got the 3 to the 10th. And then same here, we have same bases. So we add the exponents, so it's 4x plus 2. We just bring that down, and then we can just put the exponents, or set the exponents equal to each other. And that's how, and then solving for x will get you x equals 2. Okay? So if you have any questions on this one, please bring it to class, because this is fairly important to make sure we remember and understand our exponent properties, okay? So let's move down, and we're going to do number 5 together. So now number 5 has a different set of exponent properties that we need to think of. So while number 4 had multiplication, this has division. So remember, when we have division of the same base, different exponents, the exponents are going to subtract. So that's where we have the same base of 5, and then it's 4x minus 1 minus x plus 2. But it's the whole quantity of x plus 2, and that's going to be equal 5 to 6. That's still what we have on the right. Remember, we're subtracting the exponents, so we have to subtract the whole thing, which will make it 4x minus 1 minus x minus 2. So if we simplify and combine like terms, we'll have 5 to the 3x minus 3, and this will still be equal to 5 to the 6, okay? So now we have the same base equal to each other, so we can just go ahead and set the exponents equal to each other. So we have 3x minus 3 equals 6. And then we solve for x. And when we do that, we have a plus 3, which gets us 9, divided by 3, equals 3. Okay? Now, number 6 is very similar. Keep in mind that we do have a negative exponent down here. So let's go ahead and try it on your own. Once again, I will come back with the answer for this one, okay? All right, go ahead and pause. So for number 6, we get an answer of x equals 5, okay? And we have to remember that when we have a negative exponent, it flips it. So in this case, it's in the denominator, so we'll flip it up to the numerator. And that's how I got this, okay? So now we're going to go down to 7, and it's indirectly related to our exponent properties, but it's important to think about different ways to solve it. So we have 2 to the 5x minus 3 equals 4 to the x plus 6. 2 and 4 are technically different bases, but we can get 4 to have the 4, we can make it equal to 2 for our base. We just need to think about how we can get 4 from using 2. And that's where our perfect squares come into play. We know that 2 squared, so we can write 2 squared is equal to 4. We know this fact. So we can use that to our advantage in this case. So we can rewrite, I'm going to just rewrite the left side as it is. So we have 2 to the 5x minus 3 equals, now we can use this fact. So we can rewrite 4 as 2 squared times the x plus 6. And now we can distribute the 2 within this part. So we can rewrite as 2 to the 5x minus 3 equals 2 to the 2x plus 12. And now we have the same base, so we can set our exponents equal to each other. So we have 5x minus 3 equals 2x plus 12. And we can solve for x. So we subtract the 2x over, we get 3x. Add the 3 over, so we get 15. So we get 3x equals 15. And then we divide the 3 over, which will get us our x equals 5. And that is going to be our answer. Now, we can check it in the calculator. You'll see that 5x here, you get 25 minus 3 is 22. So it's 2 to the 22nd is going to equal to 4 to the 11th. And you'll see when you do that, that it does equal each other. So I'm going to have you now do number 8. You just need to figure out how you can get 9 from 3, and you'll use the same idea from number 7, and then solve for x. So go ahead and pause the video and try that out. Okay, so hopefully you remembered that 9 is the same thing as 3 squared. So that's how, so we can rewrite the left side now as 3 to the 2 times 2x minus 3. Now, before I distributed the 2 in, but in this case, I left it outside because I knew I could divide the right side by 2. So that's why I left it outside and didn't distribute. It's always safe to distribute first, and then you can go ahead and set your exponents equal to each other. But this will be your answer. X equals -4. And so with these two, we have to remember what our squares, our perfect squares. There'll be times where we have to know our perfect cubes, perfect quartics or fourths, however you want to word that. And that's how we can solve these type of problems. So that's what we have on the next page, is a lot of those, and the last two are combining some of the other, or last one, and kind of combines multiple, all 3 parts that we talked about today. Go ahead and try this page on your own. One of these will be your warm-up, or part of your warm-up next class. So I would make sure you know how to do all of these and come prepared to class to do that warm-up. But that's all I have for you tonight. Please make sure you bring any questions on this, or your homework, or anything weekly review. Please ask questions. These are all important topics, and I want to make sure we have the best understanding that we can have. Okay? But thank you for watching, and I'll see you in class. Have a good one.